In this lesson, we'll be taking a look at coordinate points on the Cartesian plane and vectors. How we get vectors out of coordinate points on the Cartesian plane. In the process, we will have to talk about position vectors, and then column vectors we will be drawing out of these coordinate points also. We have in our initial video talked about column vectors. We talked about the addition and the subtraction, the resultant. Then we talked about the magnitude of a column vector or of a vector. So let's get started. Coordinates and vectors. We should note that the coordinates actually is a location of a point on a grid or on the Cartesian plane, while the vector actually shows the change in the location of points. Remember that we had initially talked about representation of vectors as a directed line segment that has an initial point or a start point and then an end point, meaning that we use capital letters to represent the start and the end point, and then we can actually write a vector AB, and write vector CD, and write vector EF, and write vector PQ. Now we have, in that sense, join the points, for example, A and B together to form what we now call the vector AB. The point A and the point B are coordinate points that we have been able to merge somehow to give us what we call the vector AB. So we'll be seeing how we go about getting something like that in this particular lesson. Now, when we have a Cartesian plane as represented here in this diagram, the point here where both axes meet is the origin, and that will always represent as O. And then we can present any point or coordinate point on the plane with the X and Y coordinates. For example, the point A has coordinates 4, 6, while the point C has coordinates 6, 3. We will be taking a look at what a position vector is, following that simple coordinate point that we have talked about just now. A position vector is that vector that has its start point as the origin. The start point as the origin, that is the point where you have 0, 0, the point where you have both axes meet, that is the origin. Now we will label that point every time as O. So in all our discussion, the letter O will be representing the origin, or to be representing the start point for what we are going to be referring to as position vectors. In the following diagram, point A has the position vector A and point B has the position vector B. So if A is represented is in this column vector 3, 7, and then we have the coordinate of A as 3, 7. If we have the vector B as this column vector 8, 4, then the coordinate of B will be 8, 4. What this simple description is saying, we will try to reverse in our next few slides. But let me just portray here that if we have called A column vector, if we are called a position vector, it means that it is a vector whose beginning or start point is at the origin. So as long as we have been told that it's a position vector, the very X and Y components of that particular vector can directly be transformed and written as the coordinates of the vector A. I'll come again. If we have been given the vector 3, 7, which is a column vector, as a column vector, which is a position vector, then we can transform that position vector as the coordinate of the point A, 3, 7. In the same way, if we have been given the column vector 8, 4 as a position vector for B, then we can transform that particular column vector as the coordinate point of B, the coordinate point of B. In the same manner, if we are told that the coordinate point of A is 3, 7, then the position vector of A is going to be the column vector 3, 7. If we have been told that the coordinate point of B is 8, 4, then the position vector of B will be the vector 8, 4. Remember, we have said that position vector have their start point at the origin. If that is the case, then the position vector for the point A will be written as vector OA, and the position vector for point B will be written as vector OB. Let's take this example following the explanation I just gave right now. Given the points A 3, 2 and the point B minus 2, 1, find the position vectors of A and B. We have the coordinate points for A given and the coordinate points for B given. We are asked to find the position vectors of the point A and the point B. The position vector of A will be written as vector OA, and simply that is going to be the column vector 3, 2. In the same way, the position vector of B will be written as OB, and that will be the column vector minus 2, 1. These are straightforward. The only thing that we are expected to do is to convert the bracket, the way it is written as a coordinate point, convert it to a column vector or convert it to a vector in this manner. And therefore, we can write the position vector of that point A as OA and the position vector of that point B as OB. Remember, we have said position vector have their initial point at the origin, and we said that the origin will always represent with the letter O. Now, if we have the point A, the vector OA, of course, is the same vector that has its beginning or start point at O. So I have represented with the directed line segment, and the vector OC, which is the position vector OC, are presented with the directed line segment. We can be able to write the vector AC, which is the directed line segment that runs from A to C. Now, what we will be doing in these examples that follow is how to find such vectors resulting from two or more position vectors. We'll take a careful understanding walkthrough, then After that, we will summarize the whole process as a very simple step. Now let us assume we are going to find the vector AC. The vector AC should be the vector AO plus the vector OC. Remember, we are given right here the point or the coordinate point A and then the coordinate point for C. If we have the coordinate point for A, it means that we have OA as the position vector for A, and that position vector will be 4, 6, the column vector 4, 6. If we have the coordinate point C, then the position vector for point C will be OC, and OC will be that column vector that we will then write as 6, 3. So we have that AC is OAO plus OC. Of course, you can see the O's we merge and then we have AC. But remember, we do not have AO. What we have is OA. We have OC. So OC can be written right here. Why AO is not given, but we find AO from our OA. And our AO is, our AO can be found from a OA by writing that as a negative of OA. Our AO can be found from OA. The vector that runs from A to O, that's vector AO. That would be the negative of OA. So we have written minus OA, which is the same thing as our AO, now plus OC. Now rewriting that, I will also have OC minus OA. I just rearrange them, so I have OC minus OA. I want to carefully observe how this is going. Now I have OC minus OA. Remember, this C is the leading letter in the vector AC, and this A is the letter behind in the vector AC. If you remember, the vector OC is the position vector that is gotten or that will be gotten from the point C, the coordinate point C, while the vector OA is the position vector that will be gotten from the coordinate point A. And remember that the coordinate points can be transformed directly as column vectors. If I have the coordinate point A, then I can write the position vector for A as the column vector 4, 6. So I have the vector AC as the column vector OC, which is 6, 3, and the column vector OA, which is 4, 6. So that 6, 3 minus 4, 6 will give me 2 minus 3. The simplicity of what we have done here is that it doesn't need us to take these first 3 steps actually. All we need to do is to write the coordinate of C as a column vector and then minus the coordinate of A as a column vector and do the subtraction to get the vector AC. Now, why are we doing this in this manner? Because we have that A is a coordinate point, C is a coordinate point. Therefore, we can write the vector C, the vector OC as the position vector of the point C, and we can write the vector OA as the position vector of vector A. And therefore, we will come up with this solution. In our next, let's assume the question came up again this way. So a very simple way of solving it now from the understanding that we have got will be what this slide is showing. Given the coordinate points A and C find the vector AC. The vector AC will be the vector that represents the coordinate of C, that is 6, 3, and C, minus the vector that represents the coordinate of A, that will be 4, 6, and that sums up to give us 2 minus 3. If the point P has coordinates 7, 13, and point Q has coordinates 9, 6, find the vector PQ. PQ will be PO plus OQ. PQ is minus OP plus OQ because we do not have PO. PO is going to be the negative of the position vector OP. Remember, we have the points or the coordinates for P given as 7, 13, meaning that we can write the column vector 7, 13 as the position vector for P. We can also write the column vector 9, 6 as the you can write the column vector 9, 6 as the position vector for the coordinate point Q. If we have vector OP known, we have the vector OQ known, then we can have the vector PQ as the coordinate point for Q turned to column vector 9, 6 minus the column vector P, which is from the coordinate point for Q. That column vector will be 7, 13. Of course, that results in 2 minus 7. Now let's save all these processes again. Let's save all these processes. In simplicity, if the question came again, we will ignore all those processes, and then to find the vector PQ, how will that go? That simply will be the coordinate for Q, which is 9, 6, minus the coordinate for P, which is 7, 13. So what is the method here? The method is the leading letter, the coordinate for the leading letter minus the coordinate for the letter behind. Remember, it is no longer going to be coordinates, it's going to be vectors because they transform to position vector from coordinate points. PQ will be 2 minus 7. Suppose we take an example that is a little bit higher than the previous. Suppose AB is 3, 5, and AC is 2 minus 3. If the point A has coordinates 4, 6, then find the coordinates of B and C. Now we have the vector AB given, we have the vector AC given. We are given the coordinate of point A as 4, 6. We are now to find the vector B and the coordinate of B and the coordinate of C. We have that AB should be OB minus OA. Vector AB should be OB minus OA. I'm sure you know how we got there. That is the vector for the position vector for B minus the position vector for A. So vector AB is given as 3, 5. Then the position vector for B is OB. We have presented that as XY. Then the position vector for A is going to be OA. That is, OA is now the column vector 4, 6, which is gotten from the coordinate 4, 6 for the point A. The OA is the column vector 4, 6 that is gotten from the coordinates of the point A, which is 4, 6. So moving this to the other side, we're going to have our xy as 3, 5 plus 4, 6. That gives us 8, 11. And that is the vector OB. Remember, OB means the position vector of the point B. OB is the position vector of the point B. What this means is that every position vector can be transformed as a coordinate point. Every coordinate point can be transformed as a position vector. I come again. Every coordinate point can be written as a position vector, and every position vector can be written or reversed as a coordinate point. Take note of that here. So if we have gotten that the vector 8, 11 is the position vector OB, that means the coordinates of B is 8, 11. So B becomes 8, 11. Remember, we are asked to find the coordinate of C likewise. So if we are asked to find the coordinate of C, we are given the vector AC. You will agree that vector AC is OC minus OA. That is the coordinate of C minus the coordinate of A. Remember, not coordinates actually. We are supposed to write that coordinate of C as a column vector and the coordinate of A as a column vector, being that they are position vectors. So we have C as XY, and then we have the column, the position vector for A as 4, 6. How did I get 4, 6? From the coordinate point of A. The vector AC is given as 2 minus 3. So if I move this to the other side, that sums up as 6, 3. And that is our position vector for the point C. That is OC. Therefore, the coordinates of the point C is 6, 3. So we have found our B as 8, 11, and then we have also found our C as 6, 3. Here are practice exercises that we can take a look at on our own and then get to solve following the example steps that we have taken thus far.